Hey everybody, today we'll be going through the third lesson and we're going to be looking at the cosine ratio this time. So in the previous lesson we looked at the sine ratio and we are using SOH, so out of the SOHCAHTOA, and this time we're going to be looking at the CAH. And we'll explain below what that exactly means, but it will follow the exact same steps that we're using for the cosine ratio, but we're going to be using different sides to calculate. So in the triangle below, we're going to look at if we had this angle right down here. So we got theta in the corner there. And we're wanting to solve for either missing sides or missing angles. Well, we need ka. So we're looking for cos is going to be adjacent and hypotenuse. Now, opposite is right across from it. If we're looking at adjacent, it's going to be the one that is intersecting with our hypotenuse here, and that is also closest to our angle. So this is going to be our adjacent, and then this is going to be our hypotenuse. So we'll have this as our two sides that we need, and the angle in that corner that we're going to need to use to calculate for the cosine ratio. So using the cosine ratio, we have cosine equals adjacent over hypotenuse, which will look like this written out. So you have cosine theta equals adjacent over hypotenuse. And remember, theta is where your angle would be going, or it's where you're trying to find your angle. Now, if we wanted to abbreviate this and shorten it down, we have cos theta equals adjacent over hypotenuse. So you'd have I'll just clean that up so it's a little clearer, A over H. Now, if we're looking at this diagram below with the triangle filled in, we have angles that are x, y, and z, and then we have sides that are 4, 5, and 3. So we're looking for the side adjacent to angle x. So if we have our angle up here, we want to know which side is going to be adjacent. Well, it is not going to be our hypotenuse, which is 5. And we know that's our hypotenuse because it's our longest side and it's also opposite of our 90 degrees. So it's not going to be that, and it's not going to be the one directly across from it because that's going to be our opposite. So our adjacent in this one is going to be 4. Now if we're looking for the side adjacent to Z, we have our angle down here. Adjacent would be this 3. The side opposite of y, so where our 90-degree angle is also called the hypotenuse, and that'll be a length of 5. Now, if we were wanting to solve for angle x and using the cosine ratio, we would be looking at up here, we need our adjacent over our hypotenuse. So we have 4 over 5. If we're looking for angle Z, so we're down here, we'd have our 3 and our 5. So we have 3 over 5. Remember, your hypotenuse is on the bottom and your adjacent is on top for the cosine ratio. Now this is going to look similar to how we did on the last lesson where we were using sine, but this time we're going to look for what our ratio is going to be when we're looking at cos. So we'll start off with cos 15. If you type this into your calculator and see what this equals, you should end up with 0.9659. So that'll be to 4 decimal places, which they ask for in this. So we're looking at 0.9659. If we go to B, which is cos 30, we have 0.8660. So we're decreasing in value. We're at 0.9 before, now we're at 0.8. And next, we're going to be at 0.7071. Now, just like I did in the last video, I'm going to leave this next one for you to complete on your own, just to make sure that you are getting the correct value when you are putting this into your calculator. Now, an important thing when you're putting this into your calculator, make sure it is in the degree setting. So at the top of your calculator, it should say DEG. So if it says RAD, or GRAD, you have to make sure that it's saying DEG when you are calculating these. So what did you notice about the value of cosine ratio as the angle gets bigger? So we went from an angle to from 15 to 30 to 45, so it's increasing in size, the angle, each time, and our ratio is getting smaller. So as your angle increases inside, your ratio gets smaller when you're using the cosine ratio. So what angle would give you a ratio of 1? Well, if we use cos 0, we would get an angle or a ratio of 1. So if your angle was 0, your ratio would be 1. Now in the example here, it says to calculate the value of cos A to 2 decimal places. So we're looking for cos A to 2 decimal places. So we have our angle, which is A, right up here. When we're solving for this, we want to use cos theta equals adjacent over hypotenuse. We have our adjacent here, and we have our hypotenuse here. So we're going to have cos theta equals 5.3 over 6.9. Now you should know you wrote this down correct because you have your hypotenuse on the bottom, meaning the larger number should be on the bottom here. So if we do 5.3 divided by 6.9, what you're going to get as your ratio is cos theta equals 0.77. If we were asked to turn this into an angle, what we would do is second function cos, which gives us our inverse, which is our -1, and then we'd have multiplied by 0.77. This will equal an angle of 40 degrees. So that would be our angle for A. Looking at B here, we have all of the sides listed, so we have to make sure we're picking the correct sides when we're calculating for A. So A is over in this spot here. We want to use cos equals adjacent over hypotenuse. So we have to find our adjacent. Well, if that's where our angle is, opposite is right across, which would be 5.2, leaving 8.1 as our adjacent, and our hypotenuse as 9.6. So we're going to have cos theta equals 8.1 over 9.6. Now we'd take 8.1 and divide it by 9.6, and we're going to get cos theta equaling 0.84. If we were asked to turn this into the angle, we'd do the inverse. So we'd do second function cos to get our -1, and then multiplying it by 0.84, and it would give us an angle of 33 degrees. So that angle for A would be 33 degrees. Now the cosine ratio can be used to help you find missing parts of a right triangle. Remember, these have to be right triangles to use the cosine law or cosine ratio. So we have this triangle here, and we have a missing side of x. We have an angle of 33 degrees and a hypotenuse of 9.6 inches. what we want to use is our cosine ratio. So we have cos theta equals adjacent over hypotenuse. Now we have cos, and we know our angle, which is 33 degrees, equals, we don't know our adjacent. Our adjacent is going to be our x, and our hypotenuse is going to be our 9.6. Now, just like we did for the sine ratio, this is technically over 1. So we can set up our cross multiplication here, and we can multiply across to calculate for our missing x. So we'd have 9.6 cos 33 equals x. Now, if we put this into our calculator and we do 9.6 multiplied by cos 33, we're going to get x equaling 8.05, and we'd look back up here, we're looking at inches. So we have 8.05 inches, and that's going to be our final answer. Over to this triangle here, again, we have a right triangle. We have an angle of 49. We have one side, which is 7.8, and we have our hypotenuse, which is x. So we know one leg, and we don't know our hypotenuse, which is x. We'll use cos ratio, so cos theta equals adjacent over hypotenuse. We have cos with an angle of 49 equaling, well, we don't know our hypotenuse, and we know our adjacent. So we have 7.8 over our x. So we're trying to figure out what our x is. Now, this is over 1. And this was shown in the last video that when we're having our x on the bottom, what we can do is flip this over. So we flip both sides over, and what we're going to have is we'll have 1 over cos 49 equals x over 7.8. Next, we have our 7.8 multiplying up. So we're going to have 7.8 divided by cos 49 equaling x. So if we do 7.8 divided by cos 49, we end up with x equaling 11.89, and we take a look up, and we're looking at centimeters this time. So our unit is going to be in centimeters, and that would be our final answer. Now we'll slide over to the next page, and we're going to have a real life situation here. So for example 4, we have Richard McCaffrey, who works at an auto parts warehouse in Burnaby, BC. The conveyor belt he uses to move parts needs replacing, and Richard must determine approximately what length of belt to order. He knows that the angle of depression from the upper floor along the conveyor belt is 38 degrees. Now, that's a review from last lesson where we talked about the difference between angle of depression and elevation. So we have an angle of depression here of 38 degrees, and the belt reaches the lower level at a point 6.1 meters further along the floor. What we need to do is determine the length of the conveyor belt that Richard needs to order. So they've done a diagram for us here. We have our angle of depression, which is 38 degrees at the top. And it also mirrors this angle right here, which is also going to be 38 degrees. We have a length of 6.1 meters, and we're trying to find out what length the belt is going to be. So we're trying to find out what Q is. So we have to figure out, using cos theta equals A over h, so adjacent over hypotenuse, what's going to fill in the information on this formula. So we have cos, and our angle is going to be 38 degrees equals, well, if we're looking at this here, our adjacent is going to be our 6.1, and our hypotenuse is going to be our q. So we're trying to figure out what our q is. Now, this is all over 1, and we can do our cross multiplication, but this time we have our variable that we don't know on the bottom. A faster way to do our cross multiplication is to just flip this over. So we're going to flip it over. So we have 1 over cos 38 equals q over 6.1. Now this 6.1 will multiply up, and what we'll get is 6.1 divided by cos 38 equals q. Now we can do 6.1 divided by is equal to 7.74, and if we look at the unit that we have for the bottom distance, which is in meters, we'd have 7.74 meters, and that'll be our final answer. For example 5, in construction, Mary knows that the force acting at an angle can be broken into a vertical force and a horizontal force. If a force of 365 newtons is exerted diagonally downward at an angle of 30 degrees to the horizontal, what force will be applied horizontally? So they've given us a diagram here to understand exactly what we're talking about. We're looking at 365 newtons of force this way, which is going across our hypotenuse. Then we have an angle at the bottom, which is 30 degrees, and we're trying to find out x. So we're essentially looking for the number of newtons that are going to be applied in that direction. So we have to solve using cos. We have cos theta equals adjacent over hypotenuse. Well, going by the information we have cos and an angle of 30 degrees is equal to, now we have adjacent over hypotenuse. Currently, our adjacent is x, so we don't know what x is, but we do know our hypotenuse, which is 365 degrees. Now, remember, this is all over 1, so we can do our cross multiplication. And because our variable is on top here, we can do x equaling 365 multiplied by cos 30. Now, by multiplying that, we should find out that x is equal to 316.1, and our unit is newtons. So we're going to have 316.1 newtons applied horizontally here. Now that'll finish this lesson off. Remember, we're looking at cosine ratio, so we're looking at ka of the SOHCAHTOA, and we'll be looking at tan or tangent tomorrow, so we'll be finishing off that SOHCAHTOA, which helps you remember the order in which you have your fraction following it. So for us today, we're looking at ka, so cos equals adjacent over hypotenuse. Another reminder too, using your calculator, always make sure it is set in the degree mode, otherwise your calculations will be off. So always double check your calculator to make sure that your calculator is going to calculate it in the correct mode. Otherwise your numbers will always be off. Other than that, if you have any questions, please send me a message in Teams, and you're going to have a great day.